Okay, well, good morning, everybody. Don't worry about the emeritus. Stu McLennan told me when I got emeritus that he meant without merit, and it was Latin. He meant without, and so without merit is how he described the title. See quite a few student old faces in the audience. They know I like to talk a little bit of history so you get the context of what sort of a profession you're working in. And the first thing to realise is that this whole scientific process of a hypothesis, etc., was set up by Sir Francis Bacon in about 1620. So it's been around for a long, long time. And it does require a hypothesis, an experiment, data, and interpretation. And Gilbert at Rothamsted set up a whole series of long-term experiments, which are still going, and they published this statistical approach. You may not realise that all the statistics that are used around in the medical field these days, and we're all right up with stats with COVID and everything, originated there. Statistics was brought in to analyse agricultural experiments, and that's quite important. So it underpins all our algorithms, etc., meta-analysis of data that comes through, and of course we're interested in that from an agricultural perspective, but it underpins all the things. When you use your phone, all those sort of algorithms and that started off life as a set of equations to do with agriculture. Obviously they've been modified, but that's the basis. So the process itself, and so Ian and the organisers here told me they wanted me to talk a little bit about the process of science, and most of you have gone through this process yourself and do it with your clients. But the key thing is to identify the issue to be studied. You'd be horrified, I think, sometimes to realise how often people haven't read the literature and don't actually know the problem that they're about to sort of study. So you pose a hypothesis, which is all about stating what you think will happen, and you test that, as Ian pointed out before. And you need to design experiments around that with correct statistics. And it's painful as a scientist to have to go through replication and all the rest of it, and then after you've done a couple of years' work, you send it off to a journal, and you get some pedantic, bloody statistical referee who comes back challenging you on why did you analyse it this way or that way. And I said, well, I don't know, but I asked the statistician and they told me to do it that way. So, but you do need to analyse results with statistics. That's extremely important. And I think that gives you the confidence, as Ian was saying, that something is going to happen. It won't happen all the time. After all, statistics says you accept it with 95% confidence. That means 5% of the time the result may not be the way that you're stating. So you need to understand those things. And you need to come to some conclusion. The hypothesis is correct, it isn't correct. You can find statistical differences, but this is where you guys really come in. Is that really important in a commercial sense, or even in a biological sense? And sometimes those differences, anybody can say it's statistically different, and it will show it, but a 2% change in digestibility, does that really make a difference to the bottom line? And no, it doesn't. So those are the things where you need to put it into context about those sort of results. You publish in peer review scientific journals, for example, Animal Production Science, and I recommend that you just keep getting updates on those things. It's a really good way of finding out what's happening, particularly in Australia. And then there's the other aspect is the meta-analysis. So somebody sits down, there's been 30 experiments done around the world on this particular topic. Let's just see what the data actually shows. And there is a statistical procedure about how you go about meta-analysis. It's a way of collating all the information. For example, you have a lot of them. Do they actually conclude about the broader or validate the broader conclusions? For example, there is only a urea response in cows when grazing spear grass less than 7% crude protein. There are a lot of experiments around, particularly on Mitchell grass, where you don't get responses to urea, when you think you should get responses to urea. So there are scenarios like that you pull out with a meta-analytical approach. And they are, I find them really good. I mean, I've actually had to review a couple of them from Brazil recently, and they look at a whole broad range of experiments in supplementation there, and what are their conclusions. And you get really good take-home messages by going through that process. I mean, I generally tend to ignore the statistical section of the paper because I don't understand what they're doing, but I do look to the take-home messages in that. And don't look locked into convention. Look for outliers and opportunities. And we have an excellent example this afternoon talking about algae and methane reduction. You know, Rob and those guys looking for things that don't follow the theory, that's where you make major advances. The process is slow and careful. You've only got to look at the COVID-19 pandemic and the experts that are on TV all the time telling you about that. And who do you believe? The scientist or the politician or the blogger or whoever else is coming through on Facebook telling you about what's actually happening? And you ought to realise, and I'm sure you do, scientists do not always agree. I mean, that's the whole basis of a scientific process, is to argue like hell. Tim will tell me something and I'll take the opposite view just to see how good he really is. Or is he on that spectrum that Ian was talking about, you know, the one on the left, really confident but didn't know much? Or had he come to the conclusion at the end that it's a bit more complicated than I thought? So the peer-reviewed articles are published in scientific journals, and I indicated Animal Production Science is a good one, but there's a Journal of Range Management, Australian one, and there are international journals which publish from around the world on similar topics, and you can do searches on those, and they're quite easy to do, and it's a good way of finding out what other people are doing. There are reputable websites which collect information. So we have the MLA, the government ones, university sites, Wikipedia and Google. I use Wikipedia and Google. I hate to tell the students that are in the audience that I used to use Google a lot when I was trying to find a slide or put something else up. You know, you need to use common sense when you're looking at that information. You need to regard other sorts of sites with some scepticism, but some of the company websites are really quite good. I mean, okay, yes, there might be a bit of magic in what they're trying to sell, but they do want to sell their product. And if you go through it and look at what they're saying, sometimes you get some really good information about what they're basing that message on and whether you have some confidence in that. And your own observation and that of your friends, but you use common sense and rely on the data collected correctly. So recently a group of us looked at the centre pivots in the Pilbara and Kimberley region, and I'll show you a little bit later, 2 booklets produced, one by the Kimberley and Pilbara Cattlemen's Association and one by the West Australian DPERT. Really excellent booklets in collating the information across a range of sources. But one of the things that really struck me that there were two large properties there that were using centre pivots on a large scale, and they had weights in, weights out, time periods, amazing data set that you could analyse and collect that live weight gain data. And they made that available to us, and it was really quite useful. So many of you work with clients. Collecting data correctly is very valuable, and the large data sets are quite important in that. And to believe the data if it's been measured correctly in that scenario. Where do I access? Well, MLA, state government, university websites are key ones, but there are other ones around. I'd just point out Future Beef. I mean, a couple of us are reviewing Future Beef and going through all the articles that are on there at the moment and as part of the process of reorganising it. But I've been absolutely amazed. I mean, I must have been living, you know, in a black hole somewhere because I didn't realise half the things that were in Future Beef, and there are some really excellent articles in that particular book, well, it's not a book, a particular website about what is going on and where you can access information, etc. There are industry booklets, and you know, the Weiner Management, for example, is one such booklet that MLA has put out. There's a number of them, and I found them really useful for teaching, but I think that they are really excellent source material. Consultants, the people in this audience today. I mean, you have your clients, you have your own databases, your own benchmarking aspects. You know what's going on. Now, sometimes, you know, there's commercial in confidence, etc., in terms of sharing that, but nevertheless, it's an extremely valuable resource. Probably even more so than some of us who work in the science field, because you've got real-world scenarios and what's actually happening with that. Reproduction rate, for example, as Ian talked about, people quote all sorts of, I'm getting 70% or 75% or whatever, but if you go back through the data or look at sales, you come up with quite a different picture. You might get 40% one year and 80% the next year. Well, that's really good, and everybody thinks about the 80% one, but they forget about the 40% one. So that drops you immediately down to 60% overall. So those are the sorts of things. There are other country extension agencies which are also provide good information around various topics. You can search for those things. As I said to you, Google Scholar is a really good one for giving you the scientific papers around that. And particularly some of the websites. I like those 1 to 4 pages. I was on Ian's spectrum of hugely confident at the start, and I want to whip through right to the end where I'm kind of things a bit more complicated than I think, but I've got a message here that I can talk about. And there are producer agencies, and I mentioned the KPCA booklet. The WA DPERT also has one out on the centre pivots. Really excellent booklets, and you can get them online. There are electronic versions available as well. So this one came out last year for the centre pivots over in that part of Australia. So why do science and payback? So once again, a little bit of history. Ted Hensel was the chief of CSIRO and then became one of the gurus, higher up within CSIRO, and he published a book called Memoirs of an Agricultural Scientist, and it's a really interesting read if you're interested in the agricultural thing. You can get it on a Kindle as well. And he went down this pathway because he needed to justify to basically Treasury down in Canberra about why the amount of money they were spending in CSIRO. So, were taxpayers getting value for money? And one of the ones that they looked at was nitrogen recycling and legumes, all of the work that was being done in the 60s. So this was in the 80s that this was being driven through trying to get this information out, and whether the investment was actually paying off. So that I won't go into all the things that went on, but the bottom line was that when he was a scientist himself, before he became chief, they did the first nitrogen volatilisation experiments at Sanford, looking at when they applied fertiliser or animals urinated on the ground, how much nitrogen came off quickly, and what actually went down into the roots that plants would take up. And those values that they got, and don't ask me what the value was, I had a mental blank, I'm getting to that age, and I can't quite recall it at the moment, but it was quite significant, like 40, 50% or more, came straight off. And interestingly, that's gone through and that's dictated our fertiliser kind of application processes. But right now, because of climate change, those nitrous oxide additions, that work, the scientific basis of the work, which was done in the 60s at Sanford, underpin some of the calculations that run for how nitrogen is accounted for in the system. Urea and Brahmins. In 1946, Ian MacDonald finished his PhD in Cambridge and published how nitrogen was recycled in an animal. People didn't know where cattle got their amino acids from and what was actually going on. And then he became chief of CSIRO down in Prospect in New South Wales, for Australia. But that showed that the urea that was recycled in saliva provided a nitrogen for the microbes which synthesised all the amino acids. And in fact, a little bit later, a guy who got a Nobel Prize for it showed that you could raise animals just on urea alone without any protein. But I think the important one for us is in the 70s, Lyle Winks at Swans Lagoon published a series of papers on the use of urea in cattle grazing speargrass and the differences between Bos indicus and Bos taurus breeds. And I personally think this is the best applied research that was ever done in Australia, definitely in the north, but in Australia overall. Because it identified a problem, it showed breed differences, it looked at when you would get a response to urea, and out of that came the whole urea supplementation story that we use today. The other one is the Lucchina story. And I think that the Larson family and Matt Shelton driving that, but it focused on two key issues as barriers for adoption, and that's what I think is an important thing when we were talking about adoption, why don't things get adopted? Oh, 5 minutes. Well, I better move on. But the bottom line was that they identified the best practice management for the establishment of leukemia by using people who knew how to farm properly, and they looked at the toxicity issue, which was Ray Jones's work. And on Wambiana, it's a large-scale long-term grazing experiment, and I think that that's going to be one of the most important long-term experiments that we've run in Australia by providing the information about stocking rate and now carbon capture, etc., that goes through. And just to draw your attention, this is work from Stu McLennan on the role of leukemia and talking about what Jason was talking about earlier about quality of meat. Leukemia in the system, as I'm sure you're aware, pushing those growth rate of those animals up to 2 years, a bit over 2 years, versus the more traditional way of 3.5 years. But you could also do that with supplements as well. So there are different strategies that you can use. So the role of producers are quite important in this. Their own observations and experience, people know their country, and detailed observation of what's happening. The visual is less reliable, but quantitative data is more important. So we've got a range of things that we can monitor now, and there are many more tools for us to be able to monitor those things. Always remember about paddock variation, which people in producer demonstration sites don't tend to take account of, but that's really an important part of interpreting. But I think that benchmarking and collecting data and using it, as most of you, and especially in the commercial world, benchmarking is probably one of the most important business tools that you have to identify where the problem actually is. And then you can also use bigger researchable issues about providing support for bigger programs or getting people to to work on a problem. I don't think scientists are usually very good at identifying a commercial problem. And it's one of the good things about coming to meetings like this, where you hear about what are some of the big issues facing the commercial world. The role of the regional beef research committees and NABREC are really important in this process of feeding back, but there is also the way that you feed back through your client base. There are examples, and we've heard about those. The phosphorus supplementation on the Barclay tableland was identified about 1956, and we just had it got cancelled because of COVID, but there was a recent field day going to be held at Daly Waters, or before that at Kidman Springs. But anyway, it didn't eventuate. Top of the list on that particular field day, phosphorus supplementation. What is it, 70 years later? But nevertheless, as Jason said, there are issues and ways, one person at a time, about how you go about this. But I think one of the things is identifying why don't people take it up? Where is the problem? Kidman Channel Country, on the Kidman properties, they had long-term monitoring of plots with and without cattle grazing, and with and without rabbits, by the way they put their exclusion things up. So I've got 2 minutes left. So there were she was never like this with the others, was she? She wasn't like this with Jason, I can tell you. But 30 years of data, I mean, when people start to either criticise you or want evidence about certain things, they have the data there about how their land is changing and not changing and what it's due to. And Steve Petty and Heightsbury looked at the early weaning and a standard operating procedure, of which there's publications around about doing that. Water medicators, urea supplementation, do all cattle need it? How can you save on that, etc. And the animal numbers in his work were so much greater. I mean, we're talking, if I get 50 animals in an experiment, I think I'm working overtime, they're talking about several hundred. So much more confidence in the data that comes out of that. Jeff Neath and us have recently looked at break-even supplement costs for weaners. Now, I'm going to have to require just a couple of minutes to explain this briefly, but the bottom line here is that prices are going up at the moment for cattle. At what price does a supplement pay? There are various economists around and they have varying stories about whether it pays to supplement or not to supplement. What we were interested in is what is the cost of a supplement below which we start to make money, above which we're losing money. And so this is coming out in the conference next year in the Animal Production Science meeting, and I had to get permission from Jeff to use it. But basically they used the beef cow, the herd dynamo model to look at taking heifers through and then into reproduction, and also the male animals through into live export in that scenario. The take-home message was that for about a $3.50 return, which of course is quite low these days, but about $650 a tonne was the cut-off point. So you can do a range of things. The interesting thing is you can grow under centre pivots or sort of mosaic type scenarios, forage legumes for around $200 a tonne. The dairy guys do it for that. We should be able to do it. There are a lot of different ways in which you could formulate supplements to go through. This was just generating 0.3 of a kilogram a day extra on those weaner heifers coming through, and that's easily generated simply with whole cottonseed as well. So there are a lot of different situations like that. And why should you support? And I've got to stop. Why should you support an industry approach? I think it was a bit what Jason. I'm going to keep talking just to finish. Sorry, Sally. Is that there are a lot of things which are facing your industry. You need to provide solutions to face them, which is the traditional approach. But there are challenges coming from a whole range of other sources of welfare, methane, water use, efficiency. Don't get me started on that. Health benefits of red meat, etc. And you need competent scientists and consultants with international reputations to be able to stand up and argue the toss with that scenario. I won't slow and deliberate. I'll just point you to the last one. Dodgy scientists do occur. There are problems with that. And the take-home message is really that all knowledge doesn't reside with the scientists. Benchmarking is a key tool, and there's a role of a whole range of individuals, and drawing attention to the guys, you people here, about consultants, because you have really good skills in the biological and business skills of understanding what goes on. And that's quite important in how you go through. Thank you.